to officially inform that our 8th Iron Symposium is going to start with our technical papers where experts and industry leaders come together to share their knowledge on foundry technologies. Our first speaker for the day, Mr. P. Lakshmana Kumar, Foundry Product Specialist, Laviosa India Private Limited, will be introduced by Mr. M. Arumugam, Council Member, IIF Chennai Chapter.
Good morning, gentlemen. It's my pleasure to introduce our speaker, Mr. Lakshmana Kumar Ponnusamy, a seasoned expert and with deep roots in foundry industry. A proud alumnus of PSG industry, PSG College. His career is a testament to continuous growth and technical mastery. He built his foundation where it matters most, on the shop floor. For 7 years, he served as a production engineer across 3 leading foundries in Tamil Nadu, gaining invaluable experience. Seeking to expand his technical horizon, he moved to MPM, where he spent 5 years as a technical application engineer. There he played a pivotal role in process optimization and troubleshooting, helping customer overcome the complex challenges. For the last 9 years, he has been driving force at Laviosa, starting as a technical manager. His customer focused approach and problem solving skills propelled him to a current role as a foundry technical expert. Today he provides a strategic guidance that drives real value to the industry. Please join me in welcoming a true technocrat, Mr. Lakshmana Kumar Ponnusamy. Thank you.
Vanakkam and good evening, ladies and gentlemen, and thanks for these opportunities to the IAF chapter member. First of all, I would like to thank IAF Chennai chapter. So today my topic was role of greens, premix in greens and applications. We started supplying some coal-based product to various industrial applications like a power plant and some of the foundry units we have supplied from 1933. And then our founder of this group, Mr. Ernesto Laviosa, has been thinking about what is bentonite, what is circulating in bentonite. So from the 1950, he started R&D on this subject of bentonite and what are the applications we can focus on bentonite. So from 2009, so these are the group structures what we are growing in step by step. From 2009, we have a joint venture with Premix Industries and started supplying for more applications like civil engineering, foundry applications. And from the year 2016, we started 100%. From the year 2016, we started 100% and we started supplying more over foundries. Right now, it's going on. So globally, where we are in India, globally. So more than 7 countries we are having, and then we are our headquarters at in Italy, and then we are having our own factory at Kutch-based region, and we have France, and we have Germany, and we have a unit at Spain also, and we have a joint venture at China. We have some unit in China. So we have a global appearance to recover all our grade of bentonite and then coal-based market globally. So we have performance-based minerals. We have in the consideration. We are supplying to the various categories in civil engineering, lining and waterproofing and foundry and coating and plating, and then performance minerals. So we have that various product what we are having. So the globally what Laviosa has been certified, and in India also we have certified from that Gujarat's board. So we have resubmit our mines, and we had a certificate from that government sector, from government of Gujarat. So usually now I just come into the topics of today what we are going to focus on, mainly on greens and applications. So all persons, we know what are the key factors we are considering for green sand. So silica sand, bentonite and coal dust and return sand and water. These are the major ingredients what we are using for the green sand applications. So one by one we are to be discussed about what is usually Foundry is considering about the quality factors that's in the silica sand, bentonite, coal dust. So these are the additives we are going to consider reusable condition. So the quality factor what we are considering for silica sand, the top 4 are in consideration, top 4 and medium fine grain. The medium fine grains, most foundries we are considering around that, we are considering as a good sieve distribution pattern. So in this case, the AFS characteristics, the level of fines, sieve distribution and grain size analysis. So for example, when we consider in Indian market and then European market, so European market, that level of standardization, that medium grain structure around what they are considering is 90% they are considering. So that coarser grains as much as lesser. So these are the thing what we are considering as per Indian foundries, what we are getting. This is a reference factor, the reference model, what we are getting for the coarser grains, what is the percentage is usually coming at 50 AFS number. 50 AFS number, and medium, what is the percentage what we are getting, and fine grains what we are getting. It's a reference what we are getting, those things. And then bentonite. Bentonite is the proper, it is only we are going to utilize that ensuring that between that sand grains, that bond, enrich the bonding properties between the sand grains. So what it means, whenever the return sand, they're having some clay with some dust fines, and then it having some hot stage conditions. So what is the so we are using only for the bentonite is considering for enrich the mechanical properties, green compression and wet tensile properties of the return sand green sand. So the key factors, the key parameters what we are considering for that bentonite is swelling, MBA, GCS, wet tensile strength, gelling time and fineness number. And then if you consider for that European foundries and then European standard what we are considering, and then Indian foundries, that gelling time concept what we are thinking about in Indian standards, they are not considering that gelling time parameters, and then Indian parameters, most of the foundries are considering about the gelling time parameters. These are the how we are extruding bentonite, how that bentonite crude lumps will be there. There will be some activation process will be going on. The sodium activation will be going on, and the processing the lumps material into the powder format. So what we are considering. So that most of the Indian foundries, what the parameters we are considering for that swelling, MBA, GCS and WTS, it is a passing tendency of that quality factor what we are considering. Most of the foundries is considering on this based on this below parameter. And this is an important one what we are considering to expose to our foundry team. So that quality factor that affecting that quality of level of operating in bentonite. So water quality is used in mixing, and the mixing sequence of the mixer, that AFS number of a new sand, and return sand temperature and moisture, and then mixer efficiency. These are the consideration. So we are considering. So the coal dust is act as a collapsible agent, and then what is through that lustrous carbon effect. That lustrous carbon, it has to be reduced, improve that produce the carbon barrier, and it will reduce that stand sticking tendency between the casting surface with that mold surface. So these are the parameters we are considering for that mold. These are the factors I am considering. Means I am a foundryman, so I am speaking like a foundryman. So I am considering as a foundryman I am speaking. So these are the most foundries are considering this. This as the key parameters that foundries are keeping. That VM has been 50% mass, has fixed carbon and fineness number, whatever we are consider. So the performance of coal dust. So when we are having that performance of the coal dust, the performance when it has been affected due to this n number of parameters. So that active clay, whatever the active clay percentage you are operating in your sand system, and the dead clay level, and then selection and quality of coal, and then characteristics of coal and VM of coal dust. And then selection and quality of coal and characteristics of coal dust, it is like that supplier, what we are saying, what is that swelling parameters of the coal and lustrous carbon content in their material. So these are the characteristics of coal dust it will become. So this is the point I just want to mainly comment the concept. Why premix? So we are considering why premix in the concept. So premix, it's a developed by Laviosa product. We have developed this product more than 35 years in the European market, and we are supplying a number of I think total 20 to 25 foundries in European. So well-known foundry that I came to my knowledge, it's a Brambo foundry and Gaborone foundry. We are supplying that premix product to that this thing. So whatever that interaction between myself and wherever I visited the European foundries, Italian foundries. So what is that observation? What I got from this? Uniform green sun grain structure, and ensure that efficient utilization of additives to control the output quality of green sand to optimize the moisture level in the system. So these are the points they are considering, what they are expecting, and then what they come output in premix of this premix. So usually this concept is premix versus bentonite. That is bentonite plus coal means that usual standard practice what we are considering in India. What was the standard practice what we are following? The premix concept. So return sand temperature and moisture content of the streets, return sand and mixing cycle and uniformity of the entire sand system. So this thing, benefits of premix, I just want to explain so deeper in this concept. So pre-blend of premix ensure uniform coating of the sand grains. So for example, right now we are having a premix with a pre-blend of bentonite and coal dust. So what will happen that grain structure of coal and the grain structure of bentonite is totally different. The bentonite what we are considering is 200 mesh fineness, and the coal dust is totally 200, we are not considering the 200 mesh. So we are considering a different mesh size we are controlling. So due to this, there is a chances of ununiform coating over surface in the sand grains. So what we are output this regarding surface finish. So regarding surface finish, what we are expecting is not happening. And then what we are expecting in the reduction in wet mixing time in as per SMC control, whenever we are getting that uniform coating in your sand system with what we that where we use our premix, what this thing that wet mixing time not yet increased, so we reduce the wet mixing and then we get that SMC control whatever that compatibility decided by equipment supplier, and reduction in the temperature level post moisture stage. So what we observed during that our product introduction, so that usually when we have the current practice, input of returns and moisture, the temperature is around 45 means that output is coming around 55 degree. The temperature of the output of the temperature. So what we identify during our premix introduction, the temperature of that outcome, it is 45 means it is reduced belongs to 48, 47. So that temperature increasing part has been reduced. What we say. So reduction in the water level dosage for mixing. So what we observe usually that returns and moisture we are regularly concept. When we introduce our premix in the water, so for example, usually it is coming 50 liters per batch mix if they consume means. When we introduce that level of water has been reduced up to 40 to 45 liters, 45 liters. And then most of the time I during this different concept of bentonite and sand, so usually the return sand moisture is around 1.8, and then addition of bentonite, that addition of water is around 2.5 to 3. Then totally it's come around 4.3. Then when we check that return prepare sand moisture, it is coming around 3.4 to 3.2. So from 4.2 there is a huge drop of 3.4. So this has been a little reduced because of this premix concept when we are introducing this. And then mixing efficiency will be increased. So mixing efficiency, what we consider that when we have that mixing level, that dry mixing time, usually most of the foundries are considering 20 seconds to 20 seconds, 15 seconds based on their batch mix and everything. So from that level, it has been reduced, that thing. And then reduce the AFS difference between the prepare sand versus return sand. means what I would like to say that return sand AFS number when we before entered into the mixer, it was around 55. So after mixing that prepare sand AFS, what we analyzed is coming useful, the regular practice what we are considering from 55 to 47, 46 it has been, more than 9 AFS it has been dropped. So only that fine material of bentonite and fine material of coal we are adding. So why this huge drop in AFS number? So whenever that huge drop in AFS number, it will be going to reduce your surface finish. This is the thing. This is the point we have to highlight in this point. Then effective use of bentonite in your system. So what we are, when we have this premix concept, that usage of bentonite. So that uniformity coating your sand. So if you are operating around 1 to 1.1% in your regular sand system, so it has been reduced to around 0.7 to 0.8% in your system on yours. So thank you for these opportunities, and then this is my short presentation. I think this is the first time I'm given in this open platform. Thanks for this. If there's anything is there, apologize.
Thank you, sir. Now I invite Mr. Job Yuvraj, Council Member, IAF Chennai Chapter, to felicitate Mr. P. Lakshmana Kumar, sir, with the traditional Angavastram. Thank you, sir. Now I call upon Mr. R.S. Kumar, Vice Chairman, IAF Chennai Chapter, to felicitate our speaker with a memento. Thank you, gentlemen.